All right, folks, let's get into a little bit of how to do the math problems involving law of conservation of momentum. There's two different ways I'm going to show you to do this, and we will kind of see how it works in that way. As I'm doing it, I'm going to kind of put notes off to the side on how to do each step in case there's any confusion or problems about what we're doing. So, really, what the law of conservation of momentum means is that, well, when you have momentum going into a system and no outside forces acting on it, the total amount of momentum that you have in that situation is going to be conserved or kept the same. So you're going to have that constant value going with it. The hard part's going to be, and in my regard at least, the way that I've always had trouble is just keeping things organized the way that they should be. So I've kind of come up with this method over the years, and it's worked very well for me, and it can really help keep things in line. So let's say that we've got two objects that are going to collide. We've got a dump truck, all right, mind the drawings, and we've got a smart car. All right, I wanted to pick two objects that had very, very different masses. And I don't know if you can really pick two objects that would be on a road that would have two different masses as much as this. So we have this dump truck, and let's make its mass be 10,000 kilograms. And smart car, let's make it a 500 kilogram smart car. And let's say that this one is at rest, so it's stopped. And this dump truck, let's say, is moving at 40 meters per second into the rear end of this vehicle. Okay, now we are going to have a collision. I call this little squiggle right here my collision line because that tells me that whatever happened before, I'm still going to have the same total as what I have after. So what I'm going to have to look at is what objects do I still have after? And I'm still going to have a dump truck. Probably going to have a little bit of front end damage, but it's still a dump truck. And in all honesty, it's not going to lose weight. So it's still going to have its 10,000 kilograms. And we'll have our smart car. Once again, probably a little bit of damage associated with it, but I don't need to draw that in. This isn't an art class. It's still going to have 500 kilograms of mass. Now what I'm going to need to do here is organize this stuff up and figure out what the best way to go through this is. The first one I'm going to do is called the MVP chart. Now, if we're talking about steps of what to do up here, the first thing that I should always do is draw a picture. And the picture should look a lot like what we have above here. Now, granted, you might have a different problem where these two things are sticking together, or you have two things together and they blast apart. But in general, you're going to have your two objects before the collision, your two objects after the collision. And, oh, hey, we might as well finish setting this up here. He's going 39 meters per second after the crash. Okay, so once I've drawn my picture, the next step is to figure out how much momentum each one of these guys has. There's two different methods that you can use, and I left enough space up here. I'm going to be able to do them both right underneath, and hopefully I can show you that they're both going to work the same way. The second thing you need to do is organize. Now, in a lot of textbooks and whatnot, they will tell you to call this object 1, this object 2, put some different denotation for what's happening before collision versus after collision. The reason I like drawing this like this is so that I can literally go directly underneath every single thing that I have, and all of the information I do underneath my truck is involving my truck before collision. About the smart car, before collision. The truck after collision, the smart car after collision. So, we're going to organize our data and solve. So, the only other thing that's going to be valuable here to me is remembering that mass times velocity equals momentum. The first thing I'm going to do with you here is I'm going to make what's called an MVP chart. In this case, MVP doesn't stand for what you would normally assume it to be, most valuable player or most valuable physicist. Instead, we are talking about mass velocity, and momentum, with the key thing being that the total momentum, or the combined momentum on this pre-collision line, is going to have to equal the same amount of momentum I have in my post-collision line. So this takes a little bit longer of a time to set up, but if you know how to use this chart, it actually does save you a lot of time in the functionality of solving these problems. So my mass for my dump truck is 10,000. 500 here. My velocity was 40, and I'm going to say to the right is positive because that's pretty much the direction everything's going here. At rest means 0 velocity. So in order to find momentum, my mass times my velocity equals my momentum. My mass times my velocity equals my momentum. My mass times my velocity equals my momentum. Okay? So over here, I have a grand total of 400,000 units of momentum. I'm not going to worry about units yet because it's going to fall into either meters per second or kilograms by the time I'm all said and done. So over here, I do the same exact thing. 10,000 kilograms, velocity of 39, which would give me 390,000, 500, with an unknown here. So that unknown is going to be kind of what I'm looking for. But the thing that I know is over here, my grand total was 400,000. So my grand total over here also needs to be 400,000. So that leaves this with 10,000 units of momentum necessary. In order to get my velocity, knowing that mass times velocity gives me momentum, if I take my total momentum and divide it by either of these two, it will result in giving me the other one. So in essence, I've got right here 10,000 divided by 500, so that falls off, that falls off. 100 divided by 5 will be 20. Now, not incredibly realistic because obviously this one would have to be traveling faster than this one, but in general, this is how you would solve one of these problems. Now, let's look at this in another way. If I decided to solve this using algebra, I can just say that the mass of my dump truck times the velocity of my dump truck plus the mass of my smart car times the velocity of my smart car is going to equal mass dump truck, velocity dump truck, plus mass smart car, velocity smart car. So this is where they would normally have in a textbook telling you M1, V1, M2, V2, M1, V1 after the collision, M2, V2 after the collision. I hate that notation stuff just because this all really adds in a little bit of confusion to me. By keeping things in the same lines and vertically where they should be, we should be able to plug these values in for this object, then this object, then this, and then this, and still end up with the same answer as what we had. So I would have 10,000 times 40 plus 500 times 0 equals 10,000 times 39 plus 500 times V. Well, I'm going to end up with the same exact situation I had. Over here, it'd be 400,000 equals 390,000 plus 500 V. Subtract 390,000 from both sides, and I would have 10,000. That 10,000 divided by 500 will give me the same exact answer that I had. Now, choose whichever way works for you. Both of them are going to get you to the correct answer. It doesn't matter. There's no one better way of doing it. But try this out for those practice problems I've given you, and let's see where you go from there.